Greetings. Welcome for online video session on software engineering. Myself Jagadisha, Associate Professor, Canara Engineering College, Department of Computer Science. In the last video session, we have seen about the software testing. In the software testing, we have looked on to the what is the definition of software testing, then what are the types of software testing, that is development testing, unit testing, with development testing. In the development testing, we have seen the three levels of development testing, that is unit testing, component testing, system testing. Then we saw across the various that is examples on unit testing, as well as that is equivalence partitioning. In the component testing, we saw the interface testing and types of interfaces errors, that is parameter interfaces, shared memory interfaces, procedural interfaces, then message passing interfaces. Then next we saw about there is three classes on the interfaces error type for, that is interfaces misuse, interface misunderstanding, and timing error. And we saw about the system testing, or we can call it as integration testing also. In that we saw the examples of weather data sequence, weather data sequence diagram. Then we saw the test driven development. In the test driven development, and we call test driven development as a TDD. Okay, then we saw the fundamental process of the steps followed in test driven development, and we saw the benefits of the test driven development. In that benefits, we saw the code coverages, regression testing, simplified debugging, and system documentation. This is what we studied in the TDD. Then we saw about the release testing. In the release testing, we saw the two important distinguish between the release testing and the system testing. Then we saw about in the release testing, we saw the requirement based testing, scenario testing. Then we saw the performance testing. Then we saw the user testing. In the user testing, we saw the three types of user testing, that is alpha testing, beta testing, and acceptance testing. And we saw the six types or six stages in the acceptance testing process. One is define acceptance criteria, plan acceptance testing, derive acceptance testing, then run acceptance testing, negotiate test results, and last one is accept or reject system. So these are the different types of testing what we saw in the software testing. The next part is a evolution, that is software evolution. So in the software evolution, once developing a software and releasing to the customer is not end of the software engineering process. There if any changes or any that is component has to be added, it's the responsibility of the software engineering to take care of the component, that is application. So you can consider, if you purchase any of the product, they give a warranty card for a product. The same way, whenever you develop a software, when you hand it over to the customer, it's the whole and soul of the software engineers to take care of the software. If any changes is required as per as customer for the certain period of time. So we'll see that in this software evolution topic, and in this we have evolution process, programming, evolution dynamics, software maintenance, and legacy system management. So we'll see one by one in the coming slides. Software change is inevitable. Why? So new requirement emerges when the software is used. So new changes will be keep on getting updated in the market. At the same way, the software has to be get updated as and how the changes in the market happens. The same way, the end user or the risk client has required changes in the software. So such that the software engineers has to take care of the product the developed by the software engineer. So whenever it is required, the changes has to be done according to the business changes. Error must be repaired during execution of the software or during the use of the software. There may be some changes or there must be some error be occurred. So that error has to be get repaired by the software engineer, because there will be agreement has been happen between the software engineer as well as customer. So any error has occurred in the software, that has to be taken care by the software engineers. New computers and equipment is added to the system. So whenever there is a need to upgrade the hardware in the CPU, or any component is been added to the computer, then some software may not be work properly. At that time also, software engineers has to take care whenever the new software, new hardware is been added or new components added to the system, has to be taken care by the software engineers to make sure that the software has to be work in proper condition. And the performance and the reliability of the system may have to be improved whenever there is changes in the software or has been occurred. Even the system, there is nothing but the software, has to be perform as how it was performing earlier time. The same way it has to work. So even though if you have do or added any equipments to the computer, or any changes has been done, or repaired it, the software, even though it should not, its performance should not go down, such a way that the software changes has to be done, and has to be maintain the performance as well as reliability of the system. So key problem for all the organization is managing the changes to the existing software system. See, one thing is you all know, so it is very difficult to do the alteration for the existing house. You can construct a house, you may ask for the civil engineers. They will have they will be having a problem. They face the problem in these scenarios. When they can construct a new house, but to alter the house is very difficult. So that has been also been the same problem is faced by the in the software also. It's very difficult to manage the existing software system. In the sense, do changes, or they can develop a software, new software, but to maintain the existing software is very difficult. So we come across in the legacy system also how difficult we'll come across. There is a software in the there is a existing software, how to maintain, and how difficult to maintain. So software, that's what this is the software changes. And importance of the evolution. What are the importance of the evolution? So organizations have a huge investment in their software system. They are critical business assets, so huge investment. So if they require any small changes also, they won't say something like constructing a new there's a constructing around 4 story or 5, there is a 5 floor building. So if it is required any changes in that house, so because they have constructed that house for the that's something, it has to live around 50 years. If it require any changes in that house or in that building, because they have invested a huge amount for that building, so if there is required any changes, that has to be done in that, because they have invested a lot money. They cannot demolish that house or building. So the same way in the software also, they have implemented or they have invested a large amount in the software. So if there is any problem in the system, it has to get rectified by the software engineers. So you cannot go for switch on to the new system because they've invested a lot of money. So the software engineers has to take, if there is any evolution of this software, that has to be upgraded by the software engineers. To maintain the value of these assets to the business, they must change and update. So as and how nowadays the market is also getting changes day by day. Even the software, what we, for example, if you see our that is earlier days operating system, we were using a DOS, then we can come on to the Windows 98, then we are upgraded for the XP. In the XP they have released a number of versions. So then they have started designing the Windows 7, Windows 8, then Windows 10. They keep on upgrading. So some systems may not support the Windows 10 because the hardware won't support. Some systems may not support the Windows 98 into the new system because that software may not be support that hardware. So these are the problems will be occurred in the software that is in the software organization or software companies. Even some of you may have also you may, I don't know, because you have not seen the how some of the your MUP program or as well as your EC earlier batches, the software or the that is hardware, you have to do some hardware programming where you cannot do work on the Windows Windows 8 or Windows 10 operating system. You have to go for the Windows 98 itself because the hardware supports only for Windows 98. So to upgrade for the Windows 10, you have to change the entire hardware once again to support the Windows 10. So there is a lot of investment has to be done. Instead of that, better to go for the that is older version also. That is whatever the hardware which is there or the supports to the operating system. It is better to keep the same thing. Such type of there is some evolution has to be taken care in the beginning itself. So always it is better to go something thinking like that the system whichever you purchase, it has to be in the market at least 5 to 10 years, such a way that you have to purchase the system. So even though if any changes or any software has to be updated or has to be installed in a system, your system has to be support such a way that always instead of purchasing a new system, the software, it is always better to go for new advanced technologies always, or advanced hardware which supports also software. The majority of the software budget in the large companies is devoted to changing and evolving existing software rather than developing new software. You have to seen there is always maintenance is very difficult than the purchasing any of the components. Even the car, you purchase the car, but for the maintenance as well as for the insurance only, you have to pay every year 50 to 60,000. So purchasing a car is not a big issue, but the maintenance for the existing car is very difficult. The same way, even in the software system also, whenever it is very easy to purchase to do designing new software. After that designing, is most of the budget has to be reserved for the existing software. If there is any new changes to the software is occurred in the market, that there is money has been reserved for that upgradation of the software and to maintenance the software. So this is what the importance of the evolution of the software. And you can see the spiral model of the development evolution. This is also something like a iterative process. That is release 1, release 2, release 3. You can see here that is first iteration, first, second iteration, and third iteration. That is evolution is keep on repeating. It's a cycle depending upon the market. So specification, that is specification, any changes in the market, the requirement has to be taken by the end user, and implementation of the existing software, and validation, checking for the correct input and output, what we saw in the software testing part in the virtual lab. The same way validation, then start using of the product. So this is something like a rotation, that is iteration process. as and when there is any evolution is required for the software, it has to be repeated. The process is repeated. Requirements and the design documents are not maybe not be passed from one company to the another. So this is what that is spiral model of the development process. So this is something like continuous process. So it is there is a no end to this process. So whenever the a software or the not supported by the hardware, then we have to switch on to the new application. That is new software. The existing software has to be kept for the legacy system. Because some product or it may be used for some or other purpose. So but it is instead of the software should not be misused by any of the other vendors, so it's always better to keep it in the repository for the further whenever it is required, we can make use of that software. So evolution and servicing. So initially you develop the software, and evolution, whenever the customer requires any changes, the evolution process keeps on repeating. What we saw in the spiral diagram, it's a repetition process, keep on updating. As well as servicing also is done in this same way. This what they are given in the side, there is a loop, it's a repetition, there is a keep on doing any, there is changes in the market, keep on do the evolution process as well as servicing for the existing software. Then it is phase out. So if when there is no use or from that particular software, even the number of process of evolution is over and service was also done, and where we cannot switch on to the existing software at that time, it is better to exit from that particular software and go for the new software. So that is what actually the evolution and servicing process. During evolution, the software is useful and there is a stream of the process requirement changes. So the software is modified and its structure tends to degrade and changes becomes more and more expensive. So the changes of the software will be more expensive than compared to the developing new software. There is a life cycle of the software reaches a transition point where significant changes and implementing new requirements becomes less and less cost effective. Okay, this is what actually, and evolution and servicing. You can see here evolution, the stages in the software system life cycle where it is a operational use and is evolving as new requirements are proposed and implemented in the system. Servicing, at this stage, the software remains useful, but only changes made are those required to keep it operational. That is, finding any bugs and changes to the reflected changes in the software environment, and no new functionalities added in the servicing. The functionalities can be added in the evolution, but in the servicing, something like how you go getting a servicing of your car for every 6 months, or the same way is there doing some changes, and whether the operation are working properly or whether the output are getting properly or not, because due to some software or upgradation of the hardware, you may not, the software may not work properly, or it won't support the hardware. At that time the services is required, so you can fix some bug because the bugs will be fixed due to some changes. Then due to that, by saying that, the software engineers do some servicing. The surface of the software may still be used, but no further changes are made to it. So something like all the changes has been done to the particular software. There is no need of evolution, and there is no need of servicing, and it is not able to do any changes. So that is phase out. There is then there is no use of that particular software. We have to switch on to the other new software for the application. So these are the three, that is evolution and servicing, the three phases of the software evolution. So in the examination also, they can write a spiral model of a development and evolution process, or they may ask even to write down the evolution and servicing diagram. Okay. So make sure that don't get confused while writing a diagram of the software evolution. So next, it's a evolution process. The evolution process is depending on the type of software being maintained, the types of software being maintained, and the development process used, and the skills and the experiences of the people involved. Software evolution process depends upon the software, how we want to maintain the software, and the development process used, whether the evolution can be made for that particular software or not, is also being seen in this process. And skills and evolution, that is the person who have involved in developing of an application or the software, the same team has to be maintained for the evolution process, or at least some or one or two person who are involved in that particular process has to be there for the evolution. So we cannot hand over the software to the some other person who have not involved in the application of a development of application. So where we may stuck up in the problem, instead of developing or doing evolution, it may be kept some problems or bugs where even we cannot clear the bugs also. So always it is better to have a the person who have developed the application, that's for the say the even company also will keep the same team for the evolution of the process, or if we not at all same team, at least that person or one or two person who are involved in developing of the same application during the development, they may keep it keep one or two person for the evolution process. Proposal for changes are the driver of the system evolution, should be linked with the components that are affected by the change, thus allowing the cost and impact of the changes to be estimated. So any changes has to be done for the evolution for the system. So always it is better to first, before doing any changes, it's always cost is very important. So estimation has to be done before the doing evolution. So what are the cost changes to the and that is do there's something like what are the benefits and disadvantages of doing the changes, and what is the cost will be has to be paid by the customer for the software engineers, and what are the changes has to be done in the CPU, and how difficult to switch on from new system, from old system to the new system, that or as or that are that changes has the changes has to be listed out and has to be produced in front of the that is end user. So then the end user may decide, that is client may decide whether to do the changes or not. So without that proper requirement or estimation, the software engineer cannot do the changes. So always it is better to have an estimation before doing any changes or before doing any evolution. Change identification and evolution is a continuous throughout the system lifetime. So for example, if the system of the maybe is being designed only for the something like 5 years, so in that for particular 5 years it's a continuous process of evolution. There is no end to the system changes or a system evolution. It's a continuous process. Identification of the some changes and doing evolution is a continuous process. Something like purchasing a car is not the end of the there is no need of going to the service station. It's not like that. It's a continuous process. Till your car exists with you, you have to go for the service station for every 6 or 1 year for the regular checkup of the car. So same way is a regular process till the lifetime of the system. There is no end process. So change identification and evolution process. If you see this diagram, there is a first phase is a there is a new system. So once a new system is been designed, then it is a change identification process. So for certain period of time you may make use of the system and at the end of the first year, you may find some changes for is required for the existing system. So identification process is being done. Then after that, the changing process, that is software engineers who have involved for the maintenance of the or for the evolution process of the system, he has to do he has been given a proposal or estimation for the change of that is what are the changes has been identified for the existing system. Then software evolution process, then the client or the end user may decide whether the changes is required, and whether the budget what it is reserved, and every year for the evolution, whether it meets that budget or not. If at all not, then there is no need of doing any changes. If the budget meets the requirement, then you may go for the new system, that is upgradation of the system. So this is a continuous process of the for identification of the process, then to change the proposal, evolution, software evolution process, and new system. You may also come across even in your mobile the upgradation of the OS. Android, it is some, so for some say mobile, they give upgradation for 2 years. So some mobile, there is a Android based mobile, whenever the system gets updated, or whenever the new the system or a new OS get upgraded, even automatically the Android mobiles also get. Android mobile means that is the agreement between the that is Android company as well as the mobile. Sometime it was there is an agreement between the Motorola, sometime it was agreement with Samsung, etc. like that. So depending upon that, some system may give support only for 2 years, and some system may give for till this lifetime of the mobile, etc. like that. Okay. And even some software also, it gets whenever it is upgraded in the market, even in your mobile also they get sent say the messages that your software requires a upgradation. If the memory supports, then you can do the upgradation. If your memory not supports, then there is no need of going for upgradation. Then at that time, you may not get you may not get the, what I'm saying, the changes, whatever the changes are, what are the upgradation you got for the existing system, you may not get for that system. So these are the changes. Depending upon the memory, you can get do the changes. So this is what the changes identification and evolution process. So next, the software evolution process. In the software evolution process, you can see the changes request, then impact analysis. So changes request. So for example, if you see that if you do any change upgradation of the software, that is changes request, impact analysis. What are the impact analysis if I give any upgradation? Whether the memory supports, whether my hardware supports. You have to see if I give the changes request, then if the memory is overflow, then what are the changes has to be done, etc. Something like that has to be analyzed. Then so if you see that there is no changes in this hardware, there is memory, then you can give the release planning, that is you can upgrade the system depending upon the platform as well as system enhancement, and there is what are the release planning, that is fault. If there is any fault in the system, that is release planning is nothing but you can repair the system, or you can upgrade, that is adoption of the new platform, or system enhancement, that is adding a new tool, etc. like that. Okay, that is in the release planning. And change implementation. So change implementation, that is once again, if you have come across there is some changes has to be done for the existing system, then go up to the release planning, and depending upon that is whether it is for fault repair or the adoption of the platform, or there is a required to enhance the system, you can do it. A cycle process. Then system is released. So once the system is released to the customer for a certain period of time, he may come across that there is a changes is required for the system is required. Then the process is repeated once again. So this is what the actual evaluation of the process take places, and it's a continuous process. There is a no end till is the lifetime of the is the product. So this is what the evaluation process, and it is important diagram for important part for the examination also. Make sure that. And change implementation, and the repair process both are there. So you can see this proposed the changes, there is proposed changes and requirement analysis. So in the requirement analysis, if there is required any once again any requirement analysis is required, then propose the changes. If the proposed changes is given, if your hardware is supported, or if for example if a budget is not supported, then require analysis is there, then you do the requirement updating and software development. Okay, then you can see here in the requirement analysis, it depends upon the customer whether it's product, whether it supports or not, or whether its budget is supports or not, or there is any needed there is changes in the system is been analyzed here. If it is okay, then propose changes and do the requirement analysis, then requirement updating and software development. So this is changes implementation, that is process, repetition process. Okay, is it repetition process. Then coming to this change implementation, you can see here iteration of the development process, where the revisions to the systems are designed, implemented and tested. Revision in the sense it's a keep on repeating to the system, or designed, implemented and tested. So critical difference is that the first stage of change implementation may involve program understanding. Critical difference is that the first stage of change implementation may involve program understanding, especially if the original system developers are not responsible for change implementation. So some person may develop the product, and that due to some problem he may shift one company to other company. So and no one is there involved in the team who actually the person who developed the system. At that time it will be a critical problem. So there always it is better to have or to give an agreement between the customer as well as software engineer. The one who developed the product has to be there in the company, he has to be involved any evolution of the system. At that time there will be even agreement between the customer as well as company owner, as well as company owner with the employee. So he or she cannot leave the company for a certain period of time, because the person is being involved in the development of the company, development of the product. He cannot jump to the other company, because he is the main person, or he is involved in the development of the product. And if any evolution is required, so some other cannot involve in that process, that is evolution of the process. So that has to be taken care. During the program understanding phase, you have to understand how the program is structured, how it delivers functionalities, and how proposed changes might affect the program. So if the person who are not involved in development, he or she cannot do the evolution process. If he or she is involved, because the critical point of time is required to be changes or doing evolution or change implementation is required, then I have to understand how the program is structured. So understanding of the program is required a lot of time, and what are the functionalities is required to the structure has to be analyzed, and how the changes might affect the other programs or the system has to be analyzed. So these are the that is involved in the change of implementation. Okay, and these are the urgent changes that is can arises for three reasons. That is, fault occurs that has to be repaired to allow the normal operation to continue. Okay, urgent changes request. Urgent changes may have to implement without going through all the stages of the software engineering process. In that, if a serious system fault has to be repaired to allow the normal operation to continue. If serious system urgent changes request means made implemented without going through all the stages of the software engineering process. So it is better to go the serious change system fault has to be repaired as early as possible. If changes to the system environment like OS upgradation have unexpected effects, so there is no need of doing any OS upgradation. So you may not come across that these changes. If you want to do any OS upgradation, whenever you are doing some programs like new PA or something like that is open source software, when you are doing executing, if then there may be OS or maybe the open source, the pop-up will come, please upgrade your there is a system, or please upgrade your application, that is software. If you give yes, then it gets upgraded, then the program which is saved in your system, if you want to execute in the open source, some not like normal that is compiler, so like so there is a compiler where it supports a larger system, that is larger system in sense larger software. At that time it won't support. You may come across in short period of time, because people have to be designed some that sort of say software, that is application has to be designed in the there is OP skill development in the 5th semester. So you may come across all this type of problems. So my sincere advice, if there is any open sources, please don't give any upgradation. So first you save your programs and you get the output, then you can give a upgradation, that is better. And if there are business changes that is required a very rapid response, that is release of a competing product, and these are the that is urgent changes are requested. Yeah. So emergency repair process. So whenever any repair process is required, because you have to release a product or you have to give a service to the customer, at that time change request, analyze the source code and modify the source code and deliver the system to the client. That is better always. If there is you may know that there is a change is required for the system, but as far as customer is not asking any changes and his business is running very smoothly, then why do you do the changes? So as far as there is any emergency, that is repair is required, analyze the source code, modify the source code as far as the old system and deliver the product to the system. That is better always. So when the customer didn't ask any changes, then it's better to not to do any that is changes to the system. So do the repair system and deliver the product to the customer. That is a better option, and that is a better ethics for the software engineer also, not to involve much for the client. What is asked, it is better to deliver the services for the same. Not you should not give any idea. Whenever it is a new system, that is better. When it is a whole system, there is a repair is required. There is where the critical in the business, that is at that time it's better to give a emergency repair to the process. That is better. So agile methods and evolution. In the agile method and evolution process, that is agile methods are based on incremental development. So the transition from one development to evolution is seamless one. Evolution is simply continuation of the development process based on frequent system releases. So agile method is a method like a software process, that is for software process model like waterfall model, incremental model. This is also agile method is also something related to that. But here it's not that as far as customer requires, there is one stage completion, then only you have to move on to the other stage. It's not like that. In all the stages, all the people are working here. So any changes is required, that changes in that particular stage is done and release release the method to the next stages. And in that stages also, if there is any changes required, then send the previous changes. There is no set of rules is required in the agile method, and it is a flexibility is good. And even most of the software engineers in the software organization, agile method is using. Automated regression testing is particularly valuable when changes are made to the system. Changes may be expressed as additional user stories. And handover problems. there is whenever where the development team have used an agile approach, but the evolution team is unfamiliar with agile method and prefer a plan-based approach. The evolution team may expect a detailed documentation to support the evolution, and this is not produced in agile process. So they may use some other method and not familiar with that particular method. Then a detailed documentation is required where a plan-based approach has been used for development, but the evolution team prefer to use a agile method. That is, the evolution team may have to start from the scratch to understand the development of the application and tested, and the code in the system may not be refactored and simplified as it's expected in agile development. So by this, I will stop this software evolution. That is first part of the that is evolution process. Then in the next class, that is program evolution dynamics, I will explain in the next online video session. By this time, if you have any doubt, you can you get it rectified or clarify it in the online class. If at all not, please once you view this video and let me know any doubt. Thank you.